Hi Pa. So in your previous video lecture we have seen about some basic concepts of magnetic circuit and its derivation, and self-inductance and mutual inductance and its derivation. So in this video lecture, based on that topics, we'll see some problems related that topics. Okay. As a small revision, so see, this is what we have seen in your last class, that is magnetic field intensity, H, B and flux. That is what we have derived in the magnetic circuit topic. So see here, one sec. See here, H is equal to Ni by L. So remember all these terms in order to solve problems. And B is equal to mu into Ni by L, and flux is equal to mu into Ni by L into A. So these, remember these terms to substitute in your problem, so then only you will have a clear understanding. Okay, so this is your problem. First problem, a ring is composed of 3 sections. The cross sectional area is 0.001 meter square for each section. The mean arc length or length A is equal to 0.3 meters, and B is equal to 0.2 meters, and C is equal to 0.1 meter. An air gap length of 0.1 millimeter is cut into the ring. Okay, the relative permeability of sections A, B and C are 5000, 1000 and 10,000 respectively, since they are of different materials and they will have a different permeability. The flux in the air gap is 7.5 into 10 power minus 4 Weber. Okay, the question is to find MMF, magnetomotive force, and exciting current if the coil has 100 turns, and reluctance of the section. So that is what the question. So the given data are, okay, area of the cross sectional, or for a air gap for the coil A, for the coil B and coil C is 0.001 meter square, and the length of that each material is that LA is equal to 0.3, LB is equal to 0.2 and LC is equal to 0.1, and LG is equal to 0.001 meter. Okay, LG is equal to 0.1, and it is also named as, you can write in meters. Okay, 0.001 meter. Then the permeability of each material is that for material A the permeability is 5000, for material B it is 1000, and for material C it is 10,000. So now the flux is also given, that 7.5 into 10 power minus 4 Weber. So with this we have to find the MMF, exciting current and the reluctance. Okay, the air gap and the 3 sections form a series magnetic circuit. The flux in the air gap is same as that of 3 sections. So hence total MMF is sum of the MMF for each part of the magnetic circuit. So the total MMF is sum of the MMF. Okay, so how can you find the total MMF? Sum of the MMF. So MMF is equal to H into L, or MMF is equal to Ni. Okay, so if now only we had a small recap. Ni is equal to H into L. That is what here we have chosen to write. So the total MMF, we know that we have, so from the question we didn't have a H, but we have Lg. So but we have flux, so we have to write the H in terms of flux. Okay, so for H we can write as B by mu naught, that is with related to magnetic flux density. So the magnetic field density can be related with magnetic flux density from the derivation, that can be written as B by mu naught, B by mu. So mu is equal to mu naught by mu r. So substitute in all the H values. Okay, next, so instead of B is also not given in the question, but flux is given. So okay, now the B can be written in terms of flux, that is phi by A. Phi by A, B is equal to phi by A. So now the equation will be as this. Now we know all the terms, that is flux is also given, length of that metal is also given, permeability is also given, and area of that cross section area of that metal is also given. So substituting all the terms you will get, so you can take the common values outside. Okay, on substituting like this you will get a value of 220.83 ampere turns, A for ampere and T for turns. So that is what your MMF. So next question is what? Exciting current. So exciting current, we know that MMF is equal to Ni. So N is given. Now we have also found out the term MMF from this from your previous question, that is 220 into 8.380. Now you just want to directly substitute those values and find out the I, that is 2.2 A. Next one is reluctance of each section. The formula for reluctance is LA by mu naught mu r AA. Then you have to find out for each section individually. On finding for each section individually, you will have terms like this. So this is what the reluctance for each section. So section A, section B, section C, and for air gap 2. Okay, the value formula is LA by mu into A. LA by mu into A. Mu is equal to mu naught into mu r. LA by mu into A. So remember that. So mu is equal to mu naught is equal to 4 pi into 10 power minus 7. Okay, mu naught is equal to 4 pi into 10 power minus 7 for mu r. For air gap, mu r is equal to 1. For air gap, mu r is equal to 1. So other things are given in the question and the problems have been solved successfully. Okay. Now let us see another problem that is relating to self-inductance and mutual inductance. So read out the question. The field winding of the DC electromagnet is wound with an 800 turns and has a resistance of 40 ohms when exciting voltage is, okay, that is your EMF, is 230 volt and the magnetic flux around the coil, that is phi, is equal to 0.04 Weber. Calculate the self-inductance and the energy stored in the magnetic field. So we know that formula for self-inductance N is equal to N into phi by I. That is we have derived as N into d phi by di, but in common we can write as L is equal to N into phi by I. Okay, so we need N, phi and current. So in question it is given that number of turns is equal to 800 and flux is equal to 0.04, but the current value is not mentioned. Then we have to find the current value and then substitute in that and find the L value. Okay, so on find V by R is your according to Ohm's law, I is equal to V by R. We know V is voltage and R is 40 ohms, that is your 5.75 amps. Now inductance is equal to N into phi by I. Okay, N into phi by I. Okay, and substituting the terms we will get L is equal to 0.556 Henry. Remember that L is equal to Henry. Okay, flux is equal to flux unit is Weber. Turns, number of coils unit is turns. Voltage volt. Resistance ohms. I current amps. Energy in joules. Okay, wow. So see this, the field, next question is to calculate the energy stored in the magnetic field. So energy stored in the magnetic field is having a formula of half Li square. So we know L and we know I. Directly substitute the values and find out the relation. E is equal to energy stored in the magnetic field. E is equal to 9.9 joules. So now let us see another one problem and wind up the class. Now it is because of a mutual inductance. Okay, there are two coils A and B. The question is there are two coils A and B wound on the same iron core. There are 600 turns on coil A and 3600 turns on coil B. Now 4 amps of current is passing only through coil A. Produce a flux of 500 into 10 power minus 6 Weber in the core. If the current is reversed in 0.02 seconds, calculate the average EMF induced in the coil A and B. A very good question. Let us discuss. See, the question, there is a word, if this current is reversed in 0.02 seconds. The reversal means that current changes from 4 amps to minus 4 amps. So actually the change in current is 8 amps. Okay, the current is 8 amps changing. Hence the flux is for only for 4 amps, the flux produced is 500 into 10 power minus 6 Weber. So if there is another 4 amps, okay, the change, there is a change from plus 4 amps to minus 4 amps. So there will be a current of 8 amps. Actual change in current is 8 amps. Hence the flux is 1000 into 10 power minus 6 Weber. So now you have to substitute in the EMF of the coil equation and find out the EMF for coil A and coil B. So CMF in the coil A is equal to N1 into d phi by dt. You know d phi is equal to 0.01. Okay, and N1 is given in the question 600 and dt is time, change in time, that is 0.02 seconds. And substitute and find out that E is equal to 30 volt in the coil 1, and for coil 2 the number of turns is 3600, 5 is same, time is also same. Just substitute and find out that E is equal to 180 volt. Okay, the question has been, the problem has been solved. Okay, but thank you ma, we'll see in the next class.